When I was a kid, I was pretty good at math. In fact, I was good enough that I could usually just look at the math problem and read the answer out. So I would do this. I would sit on the couch with my mom and I would read the textbook, just read the problem and read the answer off. And she would sit there with the answer book. I didn't need to show any work. It was just the answers were obvious. I looked at the numbers, I read the answer. And this continued throughout elementary school, throughout middle school, all the way through algebra, and even partway into geometry. And somewhere in the middle of geometry, my dad just put his foot down and said, like, no, you have to, just insisted that I had to do at least half the problems on paper. Because he said, look, someday, math is easy for you now, but someday math is going to get hard. And you will need to learn to use paper to document your thought process. You're going to need to use paper really as an extension of your brain. So you need to use paper to think. Because when math gets hard, you can't hold it all in your brain anymore. You can't solve the whole problem at once in your head. And paper becomes the way you solve harder problems. Debugging logs here in ES4 are the equivalent of showing your work in math. And so this video is me having that conversation with you that my father had with me, telling you that you need to start writing stuff down. Okay, we're building big things. By the end of the course, the scale of the digital circuits we're going to build, tens of thousands of transistors equivalent, potentially hundreds of flip-flops. We're building really big stuff. And if you don't learn to document your process as you work and as you debug, you will suffer. You will suffer perhaps some in this course. You will suffer a lot more in your future career as an engineer. So as I've looked at debug logs, the most common issue that students have just writing the debug log is that they're written as a past tense summary with a couple of problems that you encountered. Okay, so the goal of the debug log, again, like showing your work in math, is not that you have this tidy summary necessarily, but that you have a real-time log of your thought process. So what we're looking for are your real notes in lab, not some kind of curated summary that you made up after the fact. And actually, one of the TAs said this really well, that debugging log is sort of a misnomer. We want a log of the things you did, and you're going to spend most of your time debugging practically. So it's usually debugging, but not necessarily, right? It should be build log, maybe, any kind of build notes, anything that you're doing and recording as you work through the lab. So other stuff you might include any observations you have that don't make sense. And you're just like, I built something and this doesn't quite make sense, or this was weird to me, or I tried this in VHDL and it didn't work, and I found some other way to do it, but I kind of want to come back to that, or I want to make a note that that's there. Anytime you look stuff up on the internet, just paste that URL into your debug log. Any lists or tasks or notes for yourself that you have. So maybe you have a task list of things you want to accomplish for this lab, or particular components you have to do, particularly as you get later into the course and you're working on the project. Just keeping track of all the different tasks you have to do can be part of the debug log as well. Okay, let's look at a few reports that exemplify particularly good things. So here's one student that just did it all in their notebook. And you'll notice first there's the whole truth table, so for this 2-bit multiplication. And I assume they'd originally written this down for the pre-lab, but then they've gone through and annotated, okay, this case all work. This case they've marked as doesn't work. There's some other annotations as they're working through individual bits about things that are working and things that are not working. Then they've worked through the logic equations here, updated those as necessary. And then there's some annotations here. So pin 28 is R0, pin 38 is R1. Right, just writing that kind of stuff down is super helpful. Here's another completely different one. What this does really well is exemplify this multi-step rational process. So So R0, which was represented by an LED connected to the FPGA, isn't lighting up at all. There's clearly a problem when M0 and N0 are both on, and the LED still didn't turn on. Like, that's how I knew there was a problem. Possible cases could be, go into a bunch of different possible cases, and then explaining what the resolution was. It turned out it wasn't any of those, but that it was something in iStudio that there was a wire missing. Or it appeared to be connected, but wasn't. Here's one more. So what the student did really well was describe sort of first-person present tense. Here's what I'm doing. So to build the circuit, I'm carefully following the schematic shown in the lab handout. Looks correct, but I've yet to test it. And now I'm moving on to implementing the schematic in iStudio. iStudio doesn't allow me to do more than 2 input logic gates, so I'm going to have to redo some things. I'm correcting my sketch. Okay, now it's time to test. As I'm testing my circuit, I'm noticing the output values of the LEDs aren't always what I expect. And then I like this sentence. Rather than theorizing about what's causing this, I'm going to keep testing values of R to see if I notice any issues. And it says, oh, well, after I tested all the way through, I did notice some issues. So again, I have some beefs about perhaps the specificity of some things that the student wrote, but this kind of real-time, first-person, here's what I'm doing and here's what I'm thinking log is exactly the kind of thing we're going for. So each of these are a little bit different, and I think they each exemplify different things that are good. So the idea that the debugging log can be a living document, a piece of paper that you're just scribbling on and making notes. Right? That's one piece that it is. It's also this sort of rational debugging process aid, right? By working through some steps and writing stuff down, that it helps you just clarify your thoughts. Or maybe by taking a couple minutes to think about all the possible cases, you'll think of some things that you didn't think of before. Okay. And it is just this kind of real-time stream of consciousness log, we hope, that various things you're doing, any bits of information that you're thinking, any links or error messages or bits of code or other information that's relevant to your thought process that you might want to see later, all that stuff can go in your debugging log. And so you might say to me, well, I don't really need to take notes. I've been doing just fine in lab. I think I've got it taken care of. And this is 14-year-old Stephen talking. I don't need to write my math problems down. I can just read you the answers. Look, I mean, I've watched hundreds of students in lab, and I respectfully beg to differ with you that, yes, you may think you've got everything under control right now, but I can assure you that within a few weeks, if it hasn't already happened to you, that you will wish you had written some stuff down. Or if you don't wish you had written some stuff down, I can silently observe that you would have been in lab a lot less time if you had written some things down as you went. Okay, it may seem like a waste of time now. I can feel that temptation, right? Just like commenting your code sometimes feels like a waste of time, or just writing down what you're doing feels like. But I'm spending this time writing stuff down and not actually doing the doing. And this is why I don't mandate a particular format. So I don't care whether you write on an iPad or on a piece of paper, or whether you type on your computer, or whether you talk to some audio recording. I don't care. We'll do whatever works for you and fits in your workflow. But not doing anything is not acceptable. So ultimately, slow and steady is going to win the race here. That if you are diligent, writing things down, methodical about your approach, building things a little bit at a time and testing them as you go, and taking notes about what's working and what's not working and what you did, you will ultimately finish faster than if you just try to build everything and bash your way through it, hoping that you can quickly fix a few things and get all the debugging to just work. So the second common issue is being really vague. And I've seen tons of statements. Almost everybody has some kind of vague statement about, well, it didn't work, and then I fixed something. And so I'm just going to go through a few of these. These are composites of lots of different things I've seen. So if it resembles yours, that is simply coincidence here. When I started testing, my switch didn't work. Like, which switch? What do you mean that it didn't work? I mean, like you flip the switch and the LED didn't come on? Because that could be a problem with your switch. It could be a problem with your circuit design, your logic. It could be a problem with the LED. It could be that you just didn't have power to your circuit. Right? Who knows that your switch didn't work? The circuit did not work as expected. What do you mean by, what did you expect? What was it actually doing? Right? Don't just say it didn't do what you expected. Be clear about exactly what you expected and exactly what you got. You might say the LED didn't work properly. Well, how do you know? Again, right? Maybe it really is the problem with the LED, but how did you know that there was a problem that it didn't work properly? Did it just not come on for a particular configuration? Was it flickering? Was it turning on? Describe exactly what the symptoms are. The circuit produced the right values for all combinations except for one. Well, which one? What was the combination that made it break? And that has a pretty big bearing on what the problem might be. For example, if you're testing an AND gate and the result is never 1, that works for 3 out of the 4 combinations, but there's a different kind of approach than if your ALU gets the wrong answer for 1 out of 64 cases. And often, the solutions are just as vague. So, since you say, well, it was easy to find after I looked at my circuit again and I found the problem. How did you find the problem? What did you start looking for? What did you think the problem was, and how did you know where to look? I started testing and it didn't work because the output was wrong, and then I fiddled with the circuit and then it worked. What kind of fiddling with it? Even if you really do mean you just fiddled with it, you poke things and then something started working and you don't know what it was, it's okay to say I touched the circuit again and then it seemed to work and I don't know why. That's legitimate information. But using vague terms like I fiddled with the circuit and then it worked is not helpful. Or things like, when I connected the wires correctly, then everything started working as it should. Right? At this point, again, what do you mean by as it should? But here's where you want to go ahead and say, and then I ran through some test cases and here are the results. And you can see that I've checked off all the test cases and it works. Again, be very specific. What wires did you move where and why? And what did you mean that it started working? Okay, so how to think about the whole writing out the debug log. There's kind of this process, I think, that happens. So you're going to build some piece of your circuit. So describe what you did and what part of it you tested. Right? So generally, you're not going to build the whole thing, I hope. And you'll build some piece of it, and then you're going to find some way to test that, get some confidence that it's working. So describe what you did, and then you often will run into some kind of problem. So how did you know there was a problem? What was the anomalous test result that alerted you to the fact that something wasn't right? Right, and it could be very simple. I plugged something in and I expected the LED to turn on and it didn't. Or it could be something much more complex, that I ran some more complex test. I set up something with the digital discovery and this particular bit seemed off, or whatever it was. Then next, look at what are the possible causes. So we are naturally very quick to jump to conclusions it must be the switch, or it must be the LED, or probably my FPGA is all burned up or something. And all of those are potential causes. But take a few minutes and just think, what are all the different potential causes, right? And there are a lot of different things. And so, it's worth thinking through all of those and not jumping to a conclusion. Especially when that conclusion is I need to tear out my whole circuit and rebuild it. Or it's probably my FPGA and I'm just toast and I need another one. Those tend not to be the solutions. So the more different solutions you can think of, the better off you'll be likely. And once you've enumerated a bunch of possible causes to the problem, then how are you going to determine which one is correct? So debugging is always a process of performing tests in order to rule out potential causes. Right? So maybe you grab a voltmeter and you start measuring things, confirming that the switch really is high or low, or that that's operating correctly. Or maybe you redesign the circuit to pass the inputs directly to the outputs so that you've eliminated the logic. Maybe you set up some fixed pattern to just show the outputs. There's a lot of different things you could do to split the problem in half or isolate pieces. and get confidence, for example, that the inputs were working or that the outputs are working or that your logic is working, and then try to narrow down where the problem could be. And then finally, if it's not already obvious, and oftentimes it is, but describe what the fix is. Right? So if the problem was, oh, my LED was in backwards, then obviously the fix is to turn my LED around. But if the fix isn't obvious, then go ahead and describe what you did here. Okay, to talk just a little bit about style. I do not care if your debug log looks pretty. I don't care if you use complete sentences. In fact, concise is better. Bullet points are fine. In fact, when I'm writing debug logs, if I'm working on the computer, commonly I'll just paste error messages and code snippets and other things directly into the debug log. In fact, this is a really useful technique. Like I could just paste some error message into my debug log and come back to it, months later, and I remember I run into this error and I've seen it before, but I don't remember what the solution was, and I don't remember exactly all the circumstances, but I have this inkling that it happened before. And so I can actually search through all my previous debug logs for that specific error for some keywords and pull it up and oh yeah, no, I do remember, and I looked at these 3 web pages, and here I tried this other thing. Oh, and here's what I ended up doing. That was the solution. And so I can recapture that whole thought process because I wrote it down in my debug log. I mean, it wasn't formatted pretty, but I did have enough keywords and enough links and enough description of the solution that I could quickly reproduce it and not spend another day trying to re-debug it all over again. And I'll say it again. You're young and your brains are sharp, but they're still fallible, and you will quickly discover when you try to work on something and then come back to it months later that you just don't remember things as sharply as you perhaps thought you could. The span of projects that we work on in the university context, right? Like you rarely work on any kind of project for more than a few weeks. And in that space of time, your brain holds it pretty well. As soon as you go work on some bigger project in industry or in academia, you'll often be coming back to stuff weeks or months later that you haven't touched for a really long time. And you just can't remember stuff that long. Your brain weeds it out because it's not helpful day to day. So again, writing down notes for yourself, writing down notes for your colleagues is super important. Okay, that aside, back to style. First person active voice is fine. It's good, I think, actually. So some people will tell you that passive voice makes your writing more professional or more objective by removing yourself from the sentence, that somehow makes your writing more objective. I disagree with those people. I disagree strongly with those people. Usually I find that passive voice makes your writing harder to read and harder to understand. So just writing, you want to write for clarity, you want to write for simplicity, and anything that gets in the way of that is just worth jettisoning. Sometimes passive voice is perfectly acceptable. I don't have a hard rule against it. The goal is always clarity, and if passive voice helps with clarity, then so be it. But usually I find that it just makes things worse. So just to conclude, one student wrote in their debug log, I redid my Boolean logic and my iStudio design, and then I realized that I'd read the dip switch wrong. And I actually switched the 0 and the 1 sides. I just misread which side was 0 and which side was 1. So that meant my logic was correct all along, and I did a whole lot of work for nothing. And at the risk of going all professor on you and preaching to those who are already repentant, this is exactly why we want you to write stuff down. So when you get things wrong and there's an error in your design, oftentimes there will be subtle patterns. Right? And if you actually work through all the possible combinations, you write them down and take a minute just to examine that, you might discover it actually seems like it's doing the right thing, but it's all backwards. Some of you have done that on some of your labs. And so if you do take the time to write all that stuff down, oftentimes you'll quickly discover what the real patterns, the real problems are by seeing these patterns of inputs and outputs. But if you just start trying things like flipping switches and nothing seems to be coming out right, you'll very quickly get frustrated, and you will conclude that the solution is to just rip the whole thing out and start over again. So rarely is that the most effective thing to do. Hopefully that helps. I am trying to teach you a skill that is crucial in professional practice. And so I hope that you'll take it seriously and that you'll try to build some habits that will help you in the future. So ultimately, the debugging log is not for me. You shouldn't be writing to me. You're writing for you. At least you're practicing writing for you. And my goal is that, again, that you develop skills of documenting your work, of using paper or your computer or a text file or whatever it is to help as an extension of your brain, both as an extension of your thought process and as an extension of your memory that will serve you well, both in this course and in your engineering career beyond Tufts.